Hi, I'm Shuowei from UD Biology Department, and my lab is interested in a metalloproteinase called ADAM9, which is highly expressed in many types of solid tumors. In our previous studies, we found that ADAM9 is expressed at much higher levels in colon cancer tissues as compared with normal colon tissues taken from the same patients. And when we knocked down ADAM9 in vitro in colon cancer cell lines, we saw an inhibition of major oncogenic pathways such as mTOR signaling, as well as migration invasion of the cancer cells. So ADAM9 inhibitors may have therapeutical potentials for solid tumors, such as colon cancer. But as far as we know, there's only one published study out there which identified 4 compounds inhibiting ADAM9 activity in cell-based assays. So in this pilot grant, we propose to further characterize these published compounds and perform our own screens to identify new ADAM9 inhibitors. So we synthesized all 4 published compounds and developed a fluorescence assay for ADAM9 activity. By cleaving a fluorogenic peptide substrate, ADAM9 causes a time-dependent increase in fluorescence. However, we were unable to detect any inhibition by any of the published compounds up to 20 micromolar. At the same concentration, our positive control betinostat, which is a pan-metalloproteinase inhibitor, completely inhibited ADAM9. Because the concentration we use is 4 times as high as the published cell-based assay, we concluded that these 4 compounds are probably not real ADAM9 inhibitors, but they somehow interfere with ADAM9 activity in the cells. So next, we will focus on our own screens, but one difficulty we're facing is the high cost of ADAM9 from commercial sources. So we decided to establish our own baculovirus expression system for ADAM9, and we're able to get a high level of ADAM9 expressed. So our immediate plan is to purify the expressed ADAM9 and use it for screens. We're working with the Nemours high throughput screen facility to carry out a medium throughput screen using the library of about 2,000 FDA approved drugs and a library of hundreds of natural compounds. And eventually we would like to get into a high throughput screen for over 100,000 compounds. And once we have the purified ADAM9, we would also like to solve the crystal structure for this protease for structure-based virtual inhibitor screens. Right now, we have one manuscript in preparation on the mechanisms of ADAM9 in colon cancer progression. And we also plan to publish one on ADAM9 expression and structure and one on inhibitor screen. In the near future, we would like to submit an application for a 2-year NCI R3, but a couple years down the road, we would like to apply for an R1. So this is about it. Thank you.